Hello, hello, hello. This is the Vanilla JavaScript podcast. I'm your host, Chris Ferdinandi. Thanks so much for joining me. A few weeks ago, I shared some reasons why I don't like CSS in JS. And today, I'm going to be talking about some alternatives to it. But first, just a quick reminder that if you want to master JavaScript in 2018, head over to gomakethings.com and sign up to get daily developer tips sent straight to your inbox every weekday. You can also find a bunch of other resources for learning JavaScript. Now, on to today's show. So there are two concepts that I'm really passionate about: the lean web and the boring web. They're not the same thing, but they often work in tandem. The lean web means building websites and web apps that are lightweight, fast, and focused on user experience and user needs over bloated technology that prioritizes developers. The boring web is about using simple, resilient technologies over the fancy new hotness just because it's trendy. And most of my recommendations fall squarely within both of these realms. So for starters, I use a single CSS file loaded in the header, which is a very different approach from the way CSS-in-JS works, where all of the styles are attached to specific components that just get loaded as needed. I love writing modular CSS, but I do it using Sass files and the import function. When I actually, load my website, I'm loading just a single CSS file in the header. I'm using Sass to work modularly, but then it compiles everything into a single file for me. My CSS files tend to be quite small, and I'll get into that in just a little bit more in a minute. But if they're on the bigger side, I will inline my critical path CSS and asynchronously load the rest. Now, if you're not familiar with the idea of critical path CSS, what you're basically doing there is you're trying to identify all of the CSS that's required to render the appearance of your site in what is roughly above the fold. And obviously, the fold varies a little bit depending on the device you're looking at, how big your monitor is, and all that. But you're generally trying to target stuff that's going to be in a visitor's initial view. And then any other content that appears deeper in your site or below the fold, you don't bother loading right away. So you'll literally inline that critical stuff in the header so they get it immediately. And then you can load the rest of your CSS in the background. And that's really helpful for large CSS files. I generally don't tend to have that issue. And the magic number here is 14 kilobytes. That's the amount of data that is sent in a single HTTP request. So I use that as my cutoff for minified and gzipped CSS file size. And if my minified gzipped file is bigger than that, then I will consider using critical path CSS as an approach. I don't conditionally load my CSS based on which components are used on the page. I keep them as lean as possible, use far future headers to allow browsers to benefit from caching, and I enjoy a time to first usable content on my sites that are usually below 1 second. So you type in the URL, you hit enter, and you're going to be able to start interacting with my content in under a second. That's pretty typical for me these days. Another thing that really helps me here keep these file sizes smaller and write CSS that's more performant is using object-oriented CSS. This is an approach that was created by Nicole Sullivan. And when I first heard it, it was just like an epiphany for me, this moment of awakening as a developer. So I make heavy use of utility classes to nudge and tweak the DOM and keep my style sheets small. For example, my heading elements typically have some top padding and some bottom margin. So in my style sheet, you'll see something like H1, H2, H3, all the way to H6. Margin bottom 1em, padding top 1em. And then for my H1 element, sometimes I'll reduce that top padding just a little bit. But on my individual articles on my site, I don't want my headings to have top padding at all because I want the date to sit right above that header, nice and close. So I could write a component for that. For example, scoping H1 elements that appear within the articles class to have no top padding. But there's a good chance other areas on my site I'm going to want to remove the top padding from those as well. So instead, I use a utility class, no-padding-top. And that has only one property to it, padding top : 0. Then when I go to actually write my markup, you'll see things like h1 class equals no padding top to remove that padding from the top. If I have some other elements that have padding on them that I want to remove, I can use that same class. I don't need to write any additional CSS to do that. And it allows me to create sites that behave very predictably. I have utilities for all sorts of things: font sizes, colors, margin, padding. Those kinds of things are really good fits for utility classes, and they let me nudge and tweak my UI in very consistent and predictable ways while also keeping my CSS more dry. We talk about this principle of dry code all the time in JavaScript, but for some reason when it comes to writing CSS, we just kind of throw that all out the window, and that's silly. I also use kind of a lightweight version of BEM-ish, if you're familiar with that. And BEM is an approach to writing CSS called, or it's an acronym for Block Element Modifier, where you kind of structure your CSS in these nested hierarchical approaches. So, for example, you'll sometimes see me with things like I'll have a style for button styling, so .btn, that I can apply to both actual button elements or input type equals submit, or a link that I want to make look like a button aesthetically. But then sometimes I want to do things like adjust the size or adjust the color. So you'll see other classes like .btn-secondary to change up the color a little bit, or the appearance of my buttons. It builds on top of that .btn or .button class. So that's the base styles, and then button secondary is just a little bit of a modifier. I also have .btn-large that will increase the size of the button a little bit, the font size and the padding and things like that. So in my HTML, you'll see things like class equals btn, or class equals btn space btn-secondary, where I'm kind of just applying these classes to finesse the user interface. So that's worked really, really well for me. It's allowed me to write style sheets that are much, much smaller, and makes it super easy to throw together designs that behave consistently, because I'm not constantly rewriting the same code over and over again to get consistent looks across different areas of my apps or my websites. Just some utility classes that control most of what I do on my site. So let's talk a little bit about handling JavaScript components, because I know this is kind of another big piece of this here. So I don't use modules, I don't use imports, I don't use package bundlers, I don't install a ton of scripts from NPM, and I'm not saying you should reinvent the wheel or not benefit from the work of other people, but our obsession with libraries, tools, and NPM packages is a big part of why the web is so bloated and slow today. So here's how I work. I write most of my own code in vanilla JavaScript. I do download some third-party plugins as compiled JS files from time to time. There's a few things where the effort of writing it myself versus using an existing plugin that I think is really well done, it's just not worth it. So if I was doing kind of a really dynamic grid-based design, I might turn to Masonry by David DeSandro. Or DeSandro rather. Photo Swipe is a really nice photo layout and window box plugin that I don't think I could live without on sites that are photo intense. I take all these files, both my own code and some of these third-party plugins, I put them all in a directory, and I use Gulp to combine them all into a single file and minify them. Now, Gulp is a command line tool. In years past, I've used things like CodeKit. If you're on Windows, Prepost works too. Both of those are great. I would never tell you to steer away from them. Whatever helps you work in a quick and simple fashion is awesome. And then I load that one JavaScript file in my site or my web app. Nothing fancy, just a JavaScript file. So the question I often kind of get asked when I talk about this approach is, what happens with dependency management? Like, how does that work? And in my case, I'm working pretty much exclusively with vanilla JavaScript. I'm not using frameworks. I'm generally not using large libraries that other things are dependent on. They're usually pretty self-contained. And I choose plugins and helper functions that don't depend on other libraries or frameworks too. So I've never had to install something like jQuery or Lodash for my code to work. Generally, the only dependency that I have is browser support for some native JavaScript method or browser APIs. And how I handle those really depends on the site or app and the role JavaScript is going to play and how it works. So if JavaScript is enhancing server-side rendered HTML, which is the case for most of my sites, they work without JavaScript. JavaScript is just kind of some interactive frosting on top. And in those cases, server-side rendering and old-fashioned form submits handle almost all of the heavy lifting. And JavaScript just adds some nice interactivity that enhances the site. So it's not required for the app to work. With that type of setup, I will use something called cutting the mustard, which is a technique pioneered by the BBC. I check to see if the most cutting edge of the JavaScript methods and browser APIs I use are supported. And if and only if they are, I load my script using load.js from the Filament group. It's a handy little script that allows you to conditionally and asynchronously load JavaScript files. If I have some particularly large or rarely used JavaScript, I might conditionally load that separately. For example, if I had a checkout script that I only needed when the checkout form was present, I would do something like this. I would do if document query selector parentheses and quotes ID checkout load.js and then the path to my checkout JavaScript file. So basically, I want to make sure that element exists on the page, and if it does, then I'll dynamically load my JavaScript. But that's very rare for me. Usually, I just have a single JavaScript file for my sites. If I'm using a couple of methods or browser APIs that may have limited support, some really, really new things or some things that were implemented inconsistently for a while, like the matches method or closest are two that really come to mind. I'll include polyfills for those right in my main JavaScript file, or occasionally I'll use polyfill.io to handle that automatically for me. Now, if I'm building sites or apps that need JavaScript for their core functionality, in those cases I do three things. First, I'm going to add placeholder content to the site to make the perceived load time as fast as possible. And you've probably seen this on apps like Facebook, for example, where when you open it up, you're greeted with some gray boxes that look roughly in the shape and layout of the content that's eventually going to show up there. And they kind of like pulse a little bit as the real content is getting pulled in the background. And I'll link down in the show notes a tutorial I set up on how you can do something similar. I include polyfill.io to push browser compatibility back as far as possible. Polyfill.io is an amazing automatic polyfilling service that adds polyfills for some methods as far back as IE7, which is amazing. And then I load my JavaScript in an old-fashioned script element. So there's no conditional loading with load.js or anything in those cases. I'm literally just, script source equals and then the path to my JavaScript file. Polyfill.io is my only dependency, and it's technically not even really a dependency because it's only polyfilling browsers without native support. So on the most modern of browsers, that code is going to run even if polyfill.io fails. And usually in my scripts, I'm putting some safety checks in there so that if the methods that they depend on aren't there, they're just going to kind of not run anyways. This approach makes me a little bit of a dinosaur, but I like to think it actually makes me more of a rebel. My approach to front-end engineering, and I use the word engineering here only because we're talking about the structure and loading strategy rather than just writing code. And this approach is to many people old-fashioned. I use link elements and script elements to load my CSS and JavaScript. I'm not using frameworks or large libraries. I have no dependencies. I'm not doing any complicated bundling or package management. It's 100% boring web, but it also makes my websites and my web apps fast as hell and way more fault tolerant. I don't have to worry about failed or missed dependency breaking my code. I worry a lot less about browser timeouts on my files because they're so much smaller and they're usually cached by the browser. And I don't have to mess around with complicated build and load processes. I can literally open a text editor and build an app. A lean, boring web is better for users, and I'd argue it's also better for you as a developer. It's just a much more simple, pleasant way to build for the web. So that's it for today. If you want to master JavaScript in 2018, head over to my website, gomakethings.com, where you can sign up to get daily developer tips sent straight to your inbox every weekday. I also have a bunch of other resources for learning JavaScript available there. including the Vanilla JavaScript Toolkit, links to my Pocket guides, and this new program I just started, Vanilla JavaScript Academy, which is in its second week and has been a lot of fun for the people in it. So that's it for today. See you next time. Cheers.